Hi folks, welcome to day 26. Sorry for the delay. There was no audio on the first one, so hopefully this one works. Today we're going to be going over section 8.4, which is all on graphing the function shown. Before we jump into that though, I am going to give a shout out to make sure that you are actually making sure you're reading the announcements, because the one from Thursday was really important. Alright, so let's go ahead and jump into this. So last week we learned how to graph y equals ax squared plus bx plus c. That was our basic form of quadratic. Technically, it's called standard form. The form shown on your screen, this is called vertex form. All right, and vertex form tells us, hey, if you were to go through and FOIL these binomials and then distribute in this a and then add the k, you would end up with that same y equals ax squared plus bx plus c. All right, but it really easily tells us the vertex, because the vertex in vertex form is always h comma k. All right, so you always know the vertex in vertex form. I will note though that our h here is positive, but the h here has a minus sign in front of it. That minus sign is built into the definition, so remember that whatever your number is here, right, if we had like an x plus 2 squared, you have to remember to flip the sign. So then h would be negative 2, because the only way to get a positive by plugging in a value for h is if you had a negative h. So just remember to switch that sign. All right, so this vertex, part of why it's really awesome that it tells you that is that it actually tells you exactly how you're moving your vertex too. So we always start our vertex at 0, 0, but that x minus h business, if we have x minus h, we're moving it h units to the right, because it's h units as our x-axis, right, as our x movement or horizontal movement. If we had x plus h, we'd be moving to the left, all right, because it'd be a negative number. Over here on k controls our vertical movement of the vertex. So if we had a plus k, that means it's going up by k units, and if we had a minus k, it's going down by k units. All right, but the big thing here to take away is that we have this vertex. All right, now the nice part about vertex form is there's only 4 easy steps in order to go through and solve. Your first step in vertex form in order to graph is to plot the vertex. All right, the vertex is really easily seen in vertex form, so that's your first step. All right, step 2 is probably the trickiest step, because you have to pick 2 x values. All right, and you can pick any 2 x values you want, but I would recommend one on either side of the h, meaning that they're symmetric about the axis of symmetry. Oh, that's funny. That looks like a boot. That's fine. I'm okay with being Canadian today. All right. So, so you pick 2 x values, and since you have, right, like you have your vertex somewhere over there, right? And you know that your axis of symmetry always goes through that vertex, so that's always going to be at x equals h. All right, but the nice part with what I'm saying here is pick 2 values that are symmetric, one on either side, meaning if we go to the left 2 in order to get to my left point, I'm probably gonna want to go to the right 2 in order to get my next point, because then you can see they're going to be at the same height, and we'll see that when we go through our example. All right, but that's the second problem, is pick 2 x values. All right, our second step. After you pick those x values, you're gonna plug them in and chug them out. Plug and chug, meaning you're plugging in your x values in order to find out your 2 different y values from them. All right, it's just also called evaluating. All right, fourth and final step is to plot your 3 points. All right, so this one, we have our first point from our vertex. All right, the second and third points come from taking 2 x values and plugging them in and evaluating them into our function. And then our fourth step is to just plot those 3 points that we found in the 3 earlier steps. All right? I think that this is a little bit difficult to talk about abstractly, so let's go ahead and try out an example. All right. So if we have y equals 2 times x minus 1 squared plus 3. All right? My first step, I always like to label what's what. So I know that normally I have y equals a times x minus h squared plus k. All right? So that means that a is 2h. Since I have a negative 1 here, h is positive 1, and k is 3. I also know that my vertex is always at h comma k. So my vertex in this case, h is 1 and k is 3, so the vertex is at 1 comma 3. All right, so that's step 1. Check. Step 2. Pick 2 x values to plug in. One should be bigger than h, and one should be smaller than h. So I'm going to plug in, since my h is 1, I'm going to plug in something smaller than 1, like 0, and something bigger than 1, like 2. And we're plugging them into y equals 2 times x minus 1 squared plus 3. All right? So plugging in 0 first, instead of an x, I'm going to go ahead and put a 0. So I have 0 minus 1 squared plus 3. I guarantee the biggest mistakes you're going to be making is that you're going to forget about PEMDAS when you're going through and working on these. It's really important that you don't forget about PEMDAS, okay? You have to work with whatever's inside the parentheses first, then exponentiate, multiply or divide, then add and subtract. So we have y equals 2 times 0 minus 1 quantity squared plus 3. So since I have that 0 minus 1 inside the parentheses, I have to deal with that first. So I have 2. 0 minus 1 is just negative 1 squared plus 3. Dealing with the squared, well, negative 1 squared is just negative 1 times negative 1. So that's just 1. So then I have 2 times 1 plus 3. 2 times 1 is 2 plus 3, so y is 5. That means my point is at 0, because that's my x that I plugged in, and 5 was the y that I got out. All right. Now let's go ahead and plug in x equals 2. So I have y equals 2 times, instead of x is 2. So I have 2 minus 1 squared plus 3. All right. 2 minus 1 is just 1 squared plus 3. All right. 1 squared is 1, and 2 times 1 is 1. So I'm going to go ahead and skip a step and say, oh, that's just 2 plus 3. All right, so I exponentiated and multiplied in one step. That's okay, as long as you do them in order. So I exponentiated first, 1 squared is 1, then I multiplied. 1 times 2 is 2. All right, 2 plus 3 is 5, so my y is 5, and my x is 2. So my x is 2, comma, my y is 5, so my point is 2, comma 5. All right? And now we have 3 different points. Our vertex, the point we plugged in for the x to the left of h, and the point we plugged in with an x to the right of h. I did tell you earlier that if you picked things that were symmetric about the axis of symmetry, right? If you picked things that were the same amount away, they'd be the exact same height, right? Well, that's exactly true. So in our example, I'm going to go ahead, start drawing it out. So I have a vertex at 1, 3. So 1 to the right 1 and up 3, you have my vertex there. All right, now my 2 points I'm going to graph are right here, 0, 5 and 2, 5. So 0, 5, go up 5, that's that green point. Then I go to 2, 5. All right, 2, 5 is right up here. That's that orange point. Now all of this is nice and symmetric. All you got to do is connect that with a U. Final step, I'm going to put in my axis of symmetry. and label it. So it's at x equals -1. And that's my vertex right there. All right. So if a problem asks you to graph a quadratic in vertex form, you're going to follow these steps. All right. You're first going to plot the vertex, which is always h comma k. You're going to flip the sign on the h so that if it's a negative number inside, you make it positive. If it's positive, you make it negative. K is always the same sign. So plot the vertex. Step 2, you're going to pick two x values. And if you're smart about it, you will pick two x values that are symmetric. Meaning, if you're going to the left 2 units from h, then you're going to the right 2 units from h. All right? Pick two x's that are the same amount away from h. The third step is you're plugging in those x's that you just picked. All right, so you're going to plug them in and check them out through the function. Then you're going to plot those 3 points on a graph. So my points are 1, 3, 0, 5, and 2, 5. So I go ahead, I plot them in my graph, and I labeled my vertex and my axis of symmetry. So I'm done. All right. In your assignment today, you will not be doing the graphing or the labeling part. All right. Since you're graphing by hand, I know that takes longer. That's what you're going to be doing for tomorrow's assignment. All right, but for this assignment, all you're doing is identifying that vertex, all right, just like I did here. So identify the vertex, and then plug in your 2 points. So pick your 2 points, so in my case, x equals 0 and x equals 2, and then plug them in. All right, that's all I got for you today. Best of luck to you. Have a good one.